I think so. I think so.
Okay, so this is a quick lesson just on diluting acids and bases. So basically it's taking what we learned from solutions and applying it to acids and bases. So what was our formula for dilutions? Look at your formula sheet if you forget.
What she said.
Yep, C like I, VI equals CF, VF, or C1, V1 equals C2, V2. Yep. So we're just going to be applying that to acids and bases. Now keep in mind, you need to be studying because you have your unit exam on Friday, and it's going to tie in all these things, okay? So when you add water to an acid or base, you change, so when you add water to acid or base, you change the hydronium concentration or the hydroxide concentration. So you're making it, you got to think about it like you're making it less acidic or less basic when you add water. Diluting an acid will decrease the hydronium ion concentration, and just put that in brackets in H3O+, so that you don't have to write words, until a pH of 7 is reached. Then it's no longer an acid. Right? So diluting a base will decrease the hydroxide ion concentration until a pH, again, of 7 is reached, because then it's no longer a base. So, formulas to remember. Your pH equals negative log H3O+. Your POH equals negative log OH minus. Remember, when you think to yourself, you can find the POH of an acid, you just need to find the you can find the hydroxide ions of an acid, you just have to find the POH first. So always remember, POH goes with this one, pH goes with this one. You can't, gotta be careful. Okay? Just like in some of your workbook questions. You felt good with those, and that's good. Your H3O+ equals 10 to the power of negative pH. And your hydroxide ions equal 10 to the power of negative POH. And your C equals N over V. Your CI-VI equals CF-VF. Okay. So, and then also your molar mass equals mass over moles. Okay, those, and then 14 pH equals 14 minus POH. Okay, all these formulas, you might have to use them all in one question. Okay, or most of them in one question. So just be mindful of that. So, remember CI-VI equals CF-VF. So let's say we're given this question. A concentrated solution is made by dissolving 5 grams of HCl into 30 liters of water. So we make a concentrated solution first. You then take 10 mils of this solution and dilute it to a volume of 50 liters. What is the pH of the diluted solution? Okay. So, oh, I didn't have it there. So I'll put this, can I write on this one? Yes, good, okay. So what you need to think first is that you're making HCl, okay? You have HCl, you make that. To represent what's happening, you have to do your ionization formula and your CO minus. Okay. So what you should think to yourself is you need to figure out the concentration of these, your hydronium ions, in order to figure out the pH. That's really what our final, what we're trying to figure out. But in order to figure out the concentration of those, this is what we want to find, and this is what we're given information about. But keep in mind, it asks us what's the pH of the diluted solution. So first we have to figure out the concentration of the concentrated solution, then find the concentration of our diluted solution, and find the pH. Oops. Go ahead if you want to.
I was just going to ask if you could help me with supervision after school today because I need Mr. Stewart to do something else. Perfect, thank you.
Yeah. Okay, so we're given our mass is 5 grams, and our molar mass is 1.01 plus 35.45. So what do I got? 36.46. So my moles is equal to mass times molar mass.
Wasn't it little m big M?
It's a little unknown, but
Oh, thank you. Little m over big M. Very good.
just making sure you were listening.
Classic teacher fail excuse. So our moles get 0.1371, etc. Moles? Yes? Yeah, okay, on track. Okay, so now you can find the concentration of that. We were given our volume of 30 liters. So now you gotta realize, okay, because this is making the standard solution first, you know, and then you dilute it. So this volume is like making the standard solution. So now C equals N over V. So we get a concentration of 0.00457 moles per liter. So that's our concentrated solution to start with, but we need our diluted solution. Do you see why we need to do that? Yeah? Okay. So now I'm just going to erase this for right now because it's in my way. Okay. So now we have to go C1 times B1 equals C2 times B2. So our initial concentration is 0.00457 moles per liter times by my volume that I took out, which was 10. I need to put that into liters. Okay. So we multiply that by 0.01 liters. And what am I looking for? I'm looking for concentration. So when I rearrange to solve, I need to divide by V2. So my V2 was 50 liters. Okay, so your C2 now should be 9.14, etc., times 10 to the negative 7 moles per liter. So now stop and think about that for a minute. This was your initial concentration. This is your final concentration. That should make sense, right? Because we diluted it. Okay, so it does make sense, so that's good, so we can keep going. So what we really found was finally we found the concentration of our HCl, of our diluted HCl. But what we need is the concentration of our H3O+. Well, this formula is just all 1, 1, 1, 1 for balancing. So, can I erase this now? Oh, didn't work. Try it again. Still didn't work. Okay. So this concentration is equal to the concentration of HCl. Multiplied by 1/1, wanted over given, okay? So we know then that it's definitely 9.14 times 10 to the negative 7 moles per liter. So now we're asked to find the pH is equal to negative log of my hydronium ion concentration. So my pH is equal to negative log that answer. So I get 6.0389. So my sig digs need to be after the decimal place. I have one sig dig. So the answer is going to be 6.0. Which kind of makes sense because that's a diluted acid, right? So it shouldn't be very strong in its pH value. Okay? What if we took the negative log of this one, our initial concentration? Just for funsies. What's that pH? 2.3? 3.4? Yeah, so that makes sense, right? Because it started as a strong, like a concentrated strong acid, and now we got a diluted strong acid. Okay? So I'm going to give you back your workbooks. And what I want you to do